Yeah, so unfortunately Matt was meant to give this talk, but he is up the back and he's lost his voice somehow, so I'm just going to wing it the best I can. But before I start, I wanted to start with a little bit of a different diversion. I have a present for you, Bernd. It's a bottle of gin, and as you can see, it's purple, because when I saw it in the shops, I thought of Icinga DB and its unknown state. And if you add tonic to it, it turns pink. So.
Fantastic. We will thank you very much.
No problem.
But now it should be green.
That's right. You can make it green if you like.
Yeah,
All right. So, as said, Matt and I and my team have been working on really a couple of large-scale customers. When we say large-scale, they have 150,000 devices and many more services, and other complicated and sort of intense environments, things like TV stations and tolling infrastructure and radio equipment networks. And so these are our customers, and so when we think about how we want to monitor them, the first thing when any customer comes to us is, well, what is it that you care about? And inevitably, they don't really know, and then the next thing they say is, here's a spreadsheet of what we care about. So this talk is really about monitoring configuration at scale, because monitoring at scale is as much a configuration problem as a scaling problem, and Icinga DB will take care of a lot of the infrastructure scaling situation that we need. The largest cluster that we support has 750 primary level satellites in it, and there's a serious thundering herd problem with that. It's hilarious if you restart things, and it takes 10 minutes and a load average of 1,000 before the whole cluster calms down. Those are engineering problems that we're not really attempting to solve, I guess, and perhaps the title is really a little bit more different. But really what we're looking for is a way of creating a sustainable monitoring configuration with a large amount of scale. Scale in this sense refers to the amount of changes that are required, and to solve the problem that from 2 years down the track, 3 years down the track, 10 years down the track, we still have a monitoring solution where it can be all green all the time, and we don't end up with a bunch of things that are red and we're like, oh yeah, that thing's broken, but we don't know how to really undo the configuration, and we'll just kind of acknowledge it and leave it, and the group of critical acknowledged things just gets bigger and bigger and bigger. There's always going to be things that are broken and need fixing or taking a while, and there's a change request and all those sort of things. However, what we're trying to look for is building a sustainable pattern where we can make it so that more people can participate in the configuration process. That configuration process is better validated, and we end up with a situation which is ultimately more sustainable. So that is largely what we're talking about with the why. So what we're trying to achieve from this as well is a level of consistency out of a source of truth, using Icinga Director as a key component to take a source of truth. In this case, we'll demonstrate with Netbox, but you could use any other source of truth required. And we've done a lot of work with Netbox, and you'll sort of see why that makes a lot of sense for us, for our environments as we go through this. And that external source then lets us validate what's coming out of it, plumb those variables into the right configuration objects, and then make it so that any changes to the source of truth are reflected in the monitoring. And that really is the ultimate sort of goal here. The problem with that as well is that people will then make changes to the source of truth and break the monitoring. So there's a bunch of tricks and checks and balances involved there. And you have to, I think, clearly outline to your users that the impact of what their choices are in terms of modifying data could change things. And it's a self-referential loop, as you'll see. So, all right. So the other thing we always think about is who's going to make changes to our environment. We have users that struggle to manage anything, your managers perhaps, all the way through to someone who masters Vi. And realistically, when we're doing consulting for people, we're like, well, do you want to modify the configuration by hand? Do you want to create your own apply rules, log in, edit the configuration? And you basically need to have the skill level of someone who knows how to quit Vim to do that. And if you can't quit Vim, like we say to people, literally sit in a meeting and go, can you quit Vim? They go, what's that? And you go, well, let's do this other thing. Otherwise, they're not going to make it. So, and somewhere in between, we've got, some users that are allowed to configure things, and then there's also users that can use Director. It's a point-and-click interface. There's some validation. However, there's lots of ways you can break it. And, at scale, it gets exhausting managing Director configuration by hand. And then we're moving towards people that can actually enter inventory. So in this case, they're not actually even logging in. They might not even have credentials. Director is picking up that configuration automatically and then creating monitoring configuration from there. The users in some of these cases might not be the same people at all. So we have many customers where, for example, the guy takes an AutoCAD drawing of how a rack is meant to be laid out, and he's the guy that puts the stuff in the rack and plugs the cables in and measures all the cables out. It's all very precise and engineered, and it's his job to then enter the data into Netbox, and he does not care about exactly what happens after that. It's not relevant. His job is to make sure that the truth is documented in an accurate way, and that is what's used as a source of monitoring configuration. So, that's what we're covering off here. Sorry, I'm kind of skipping ahead. The source of truth then configures Icinga. The backup to that, therefore, is when something goes wrong, people will get a notification. The dashboard might go red. Things might happen. A new host appears, and that doesn't work. And so the first thing they might ask is, well, is the IP address wrong? Have you actually documented this incorrectly? Have you classified the host incorrectly? Because that way we've got a self-referential, sustainable system here. And then those people go back and update the source of truth. Note that they're not updating the Icinga config directly. They're going back here and making sure that this works. Now, because Netbox, for example, has lots of other value in the organization, and in particular, for example, we've plumbed it in so that not only is the configuration being sent to Icinga, notifications contain the data extracted from Netbox. So you get a notification that says this host has gone down, this is the rack that it's in, this is the data center that it's in, this is, and so instead of just getting random host 01, or many customers have like terrible host names, they're just like TTFW5655B. You're like, well, what is that? What does it do? If you can actually provide some context from Netbox in your notification, then these people can do their job better, and then they can update things and then keep the circle of life going. Okay, so how do we do this exactly? This is going to get complicated. I'm almost certainly going to make a mess of it. Matt is much better at this than I am, but we'll get there. So your import source, relatively straightforward. We have a GitHub repo that we've put a lot of effort into. We've stood on the shoulders of giants, really, to make that work, and then we rewrote it completely, and then we've continued to maintain it with future Netbox releases. And I gave a talk yesterday about Netbox, and I'll give you a bit more of a detailed demo if you like. So the important thing is to set up the import sources and then split them up into primary import source categories. Some of these end up being hosts, and some of them will end up being templates. And so when you pull in, if this was a CMDB of any type, Netbox, you'd almost certainly have the idea that a host lives in a certain place. That place doesn't become a host, it becomes a template that then is inherited. And so the import sources pull that in primarily, and then the sync rules create more qualified and detailed data out of that. We've put a bunch of effort into making it so that the code that is used to import from Netbox, for example, makes our lives easier. Netbox has this idea of an IP address always have to has a subnet mask, for example. So an IP address is not represented without a /24 or whatever. In our import code, we've made it so that that's there, but also you get another field, which is the IP address, because that's very helpful. So we've done a whole bunch of quality of life improvements, and you could have a look at our code and really adapt that to pretty much any other REST API that had similar information, and then make your life a lot easier at the import source level, so that then when you come to plumbing in complicated sync rules, you've got you don't have to keep modifying, JSON entries and doing lookups in the JSON modifiers, and I can go through that in a second. So as you scale up with these things, it becomes more and more important to really try and attempt to have fewer of these sources. One of our customers has hundreds and hundreds of import sources, and it really kind of gets out of hand when things break, and then you also get interdependencies between them because they end up relying on the sync rule might say, well, this template doesn't exist yet, and so you end up having to execute the jobs in order to make them work nicely, which is a complication. But the optimization that you can do in the code, which is effectively sitting between these two, ends up with a much cleaner result down the end. Okay, and then after that, we've got sync rules that create things like sites and clusters, and they become groups, so host groups, and then the individual devices and VMs pull in templates from those sites and clusters, which then informs things like apply rules. So for example, a classic case is, we've got a customer where they've got data centers all around the world, and all the ping checks in London need to have higher latency, because they're getting pinged from Australia and the latency is inevitably higher. That's just physics. And so the template automatically is inherited based on the site the device is in. That's a property that comes through from Netbox in this case. It sort of magically happens. Okay, we've got some practical examples. I'm going to walk through how we do it with regions. Regions, to expand further on the idea of London, regions are a parent of a site in Netbox, and that makes logical sense because that's the truth. You have a city, and that lives in a state, which is in a country, and that is followed through. This is how it looks in Netbox. You've got states of Australia and their cities. Here's a German example. That's probably not even true, actually, now I think about it, because Germany has states too, but we're ignorant about that. Sorry. Okay, we didn't realise that. New Zealand doesn't have states, I don't believe. There's no one from New Zealand here to correct me, so that's fine. But we end up with a hierarchy here, and this hierarchy ends up being plumbed into templates. As you can see here, this is how it looks in Director. Now, an important note here is that we're adding a prefix to the import. That comes in handy later when you realize how bad people are at entering data. So you'll end up with a data center that's called London, and a site that's called London, and a region that's called London, and a computer that's called London, and you end up with this total mess. So what we do is we plumb each of the different types of data objects, in this case regions or sites, or we add a prefix to them, and that's built into our importer. And that way you can uniquely distinguish between them much easier if people have entered bad data. And really this whole thing still relies on people not putting in dumb stuff. You can validate it at the import source, and we do that with custom validators. But there's still, people are going to break it. People are people, no matter how hard you try. And hey, that's why we make money as monitoring consultants, because not everyone's perfect. Neither are we, but we at least charge people for it. That's good. All right, so this is the regions then get further broken down into cities and states, and that you can see that reflecting here. So, and the tree view in Director is fantastic for this, by the way. We couldn't live without it. There's some navigation issues. We'll talk about that later, but it's all good. And then the regions get further broken down into sites. So these are some of our customers, and these are their sites, their suburbs of Sydney, and that's helpful because you can see that there are customers with multiple sites, and then the servers and devices in those sites get templates applied for that. So, for example, we can track an SLA for this customer by grouping them together on a site, or we can group them together by customer and all those other kind of things. Do apply rules based on that, do dashboards and all those other kind of things, and use that to really filter out how we make that work. We've really got to get moving. I've only got a little bit of time left. Here's how it looks in the source, and here's how it looks in the destination. We're plumbing individual types of things, like a role. We plumb that through into a custom variable, and then you can do a apply rule based on that. So this is the Netbox data in API view, and then that's the resultant Icinga configuration where the platforms are plugged in. And you can see how that's very useful. I want an apply rule that says, check all the Cisco switches with this SNMP command, and makes it super easy to do. I've got the actual code here. Where is that? How do I drag that across? For our Netbox things, GitHub. There's probably really a useful thing to keep in mind here, which we've covered. You really probably want to get the newest version of Netbox. They've made some changes to it. In particular, one of the really handy features Netbox now has is the idea of contacts. So an organization has contacts have groups, and those contacts flow through to Icinga contacts, and then when you go to a device, you can see who looks after that device and what their role is in looking after that device. Are they the architect or the support engineer or the system owner? And those can flow through into notification rules as well, all automatically. And then the company can maintain that information for themselves in Netbox, and they don't have to touch the director config or command line or anything like that. There was another point in here Matt wanted me to point out, which was he loves this Munge Fields feature, which I still don't understand. I'll get him to explain that to you later. That joins things together so you can make more sophisticated fields. And then there's a bunch of great examples here where we walk you through it. And I'd really like to encourage this as a pattern where people are thinking about where is my data stored, and that might be in a whole different database, or it might be some weird other actual database. Netbox is extremely full-featured, and I'd encourage people to use it. But the same principle applies. There was one in here we're talking about. Where was this? So this is a good example. This primary IP address. We actually flatten out that we get the IP address from the API that looks like this, but then we return that as a field into Director, so it makes your life a lot easier. And then on top of that, we're also using config context in Netbox to tag certain hosts in Netbox as satellites. So then we can create endpoints and zones from that, and those zones automatically work. We also added a feature where you can use IP ranges. So an IP range is just an arbitrary group of IP addresses. Many people lay their networks out that says this group of prefixes is this region or site. And so that's very helpful where you have a satellite that is looking after that from a firewalling point of view, and then you can automatically lay that out. And so all the hosts via the automation know which satellite to report to based on where they live in Netbox, where their IP range is automatically, and you can simply infer that from the Netbox data, which is pretty handy. And I think I'm coming near the end. So just to sum up, we're talking about monitoring configuration at scale. This is something we've used Netbox for a lot. I don't think that's necessarily the right, the only thing you could use, but Netbox is a great example. Things like info blocks and Autobot and a couple of other things have similar levels of sophistication when it comes to describing how your racks and all those things work. I really encourage everyone to work towards closing the loop on that. Keeping your general staff out of the Icinga config is a very sustainable way of making it work, and then encouraging them to have a source of truth. That means that they can maintain their documentation, have the monitoring back that documentation up with real alerts, and then actually enjoy their lives and get on with their jobs, because that's what we're here for. That's all I had. Thank you. Any questions?
Thank you, Dave. Any questions? I don't know if you asked the question, but who knew Netbooks before? Netbox? Everyone heard of this?
Oh, great.
It's just me. Now, I was
mate.
surprised, and it was like a DigitalOcean thing, right?
Yeah, yeah.
They created it, okay?
Yeah,
cool.
it's a whole company now, though. So the guy from Netbox at DigitalOcean left and now working for NS1, and NS1 is like really behind Netbox, and it's going to scale it, and it's been rapidly developing. So
very cool.
It's well worth it.
So any questions?
Hi. How do you feed Netbox with data? Do you have some kind of, I don't know, Puppet facts or Ansible?
Yes.
Or Okay.
Yes, yeah. So it depends on the customer. Netbox, I think, works best when people curate it. To be quite frank, because only people really know the truth. And for example, you can't discover which rack unit a device is in using Ansible easily. At all, actually. But we definitely have a customer where, for example, they automatically enter into Netbox from their CRM the sites, and that site automatically creates a server that lives at that site, because every server gets a site in their business. So every site gets a server, and then they use that server to index the network, and they use Ansible to gather the information from the core switches as to which VLANs are in and update Netbox. So Ansible and Netbox are working together there, and then the monitoring flows from there. And so then, for example, they can say, well, this is a switch of a certain type, therefore it's a core switch. That core switch designation flows through to a custom field in Netbox. That gets an Icinga check because all the core switches get checks for their temperature. But we don't care about the access points, for example. So there's lots of ways you can manage that. But yeah.
Any other questions? So we have about 5 minutes.
Other questions?
Yeah, in the back. I'm coming.
The nice and helpful tree view, was that in Director?
Yes.
I don't really know where that lives. I don't think I've seen it.
Let me see if I can find it for you. Where's my mouse gone? Get rid of this. Hosts. It's in host templates. So let me
Bring it on? Or?
Yeah, I think so. This is a real customer. Hopefully they don't mind. So we've got a tree view here. Yeah. So these are all sites. I don't know if they have. This particular customer, I don't think is like extremely flat, because these are all hotels, and every hotel has their own thing. But that's the tree view. I don't have a demo of the one with all the trees plumbed in, but that's how that works. We're going to reorganize this into different countries. But you can see here how the automation works. We've got a device coming from Netbox. We pull out a bunch of modifiers, we only import active devices, for example. We're pulling out the config context with the SNMP community, site name. We pull out custom fields to link them to CRMs for notifications. All those other kind of things. All this is stored in Netbox and updated automatically. And then there's a sync rule that will create things. In this case, that's for endpoints. There's server hosts here. And all those properties will then get plumbed through. It kind of gets a bit broken with some wrapping, but we've got an IP address, a device role, all the different pieces, Has RAID been detected, All that sort of stuff is all plumbed through as part of the rules. Does that help?
So good. Very good. That's really cool. Really cool.
Hi. Do you do your templates and sync rules and import stuff every time new for new customers, or do you do like imports with baskets?
We do use the baskets, and I even wrote a whole Ansible playbook that pulls baskets out and re-uploads them, and it was a big mess. But I had no other way of doing that. And for example, I was talking to you earlier about this before, where single services don't work very well, and when you have a lot of things, so we had a customer where there was very few hosts, like 8 hosts, but there was like 1,500 different checks for each of those hosts that all had different slight variants. So they ended up single services were the only way to do that, and that actually breaks in Director, and there's other problems. But and we used baskets and automation to do that, pull the basket out, edit the basket by hand using an Ansible Ginger template, re-upload the basket, and it worked after that. But for different customers, yes, we would probably just export the basic ones out and then start again and modify them. But we've refined this as we've gone along, so it ends up being every time we do it a little bit better and learn some things and add some features. And Netbox is adding features at the same time. And like for example, layer 2 VPNs just got added. We've got customers with those. Not really sure how to deal with that yet. We'll figure that out. And there's a whole other level of complication, but I'd love to tackle that as well. So yeah.
Any more questions? Yep. My pleasure.
Hi. Do you also keep individual thresholds for checks in the Netbox? Like,
Yeah.
you know, many of
Yes.
people like to use their special thresholds and
Yeah, absolutely. So two ways you can do that. One, you can just imply them from the site that they're in. But two, things like, for example, HTTP vhosts. Netbox has a JSON config context that we use for that. And so you can just chuck in the JSON, you know, Icinga, check, HTTP, list of vhosts, and that's helpful. It's not really perfect, you know. I think, you know, you're kind of stretching something like Netbox really to say, well, we've gone past layer 4 and then we're into layer 5 and 6 and 7. And it stretches the data model a little to be able to do that. But we absolutely do that, and it works really well. The config context, because it's JSON, just plumbs beautifully into the threshold checks. And we have a whole series of actual Icinga checks and plugins that we've modified to take that JSON straight away. So it just makes it really easy. You don't actually have to do a lot of work, and the users can adjust their thresholds as needs be. So, you know, things like fiber optic light levels and disk space and all those other kind of things we've plumbed in via that method, and it's worked quite well. I can give you a detailed, like a real customer demonstration that's not being recorded if you're interested in that.
Okay, so we would like to end up here and go into the next talk. So we have a chance to see Dave again, I think at 2:15 for a short talk. Again, for now, thank you very much. It was a fantastic and interesting talk. Thanks for the chin. I hope for the second talk, perhaps, no. No, thank you very much. Thanks for coming, and please an applause for Dave.
Thank you.